Hello everyone, this is going to be the fourth video of Apache Zookeeper series, and in this video we are going to see about the Apache Zookeeper data model. And this is going to be the most important video as these concepts are very important. And I wanted to just tell you one thing. In the next video, we are going to see the Java code where we are going to designing a Zookeeper. So let's get started and let's move to our node. So now we are going to see Zookeeper data model. And this is some sort of a short diagram of a Zookeeper data model where we are saying that there are some folders are defined. And it is quite similar to Unix file system. Okay, let me just make you understand a little bit Unix file system. So we can consider it as a root folder. And inside the root folder, there are the two folder, like first folder can be zoo and other folder is folder 1. And in this folder 1, there are two folders, child 1 and child 2. Zoo folder has the three folders, monkey, duck and camel. So this is how the hierarchy is maintained. The root folder has these two folders, zoo and folder 1, and zoo has another three folders. The folder 1 has the another two folders, child 1 and child 2. So it is a parent child relationship. It's a tree like structure. It's a Unix file system like structure, and we can also name it as namespace. Okay. I don't think so. It is very hard to understand this diagram now. Moving forward, we have already discussed these properties, so we can just skip them. We'll simply move to this Z node. This is an important concept. So, as we are just talking about these particular folders, so these folders are known as the Z nodes. So, let me just describe it as Z node. But now we are going to talk about these Z nodes and about the properties of these Z node and what are the data that they can store. So, first of all, the Z node can store the data in the format of string, and the max amount of data the Z node can store is 1 MB. So why it is 1 MB? Because Zookeeper is not a database. It stores the data up to 1 MB because it is to store the configuration to maintain the state of the systems. It is not going to store the data like a database. Now, this is the first property of a Z node. Second property is that it's always stores the when the Z node is going to be created, it is going to be start with a slash. Like it is going to be in a format of a folder. Like slash abc slash pqr, and you can also name the Z nodes with some alphanumeric character like slash ab123. The only thing that you cannot use in the naming convention of a Z node, that is a dot or like a full stop or something. Now there is a one more thing, very important concept of the Z node is access control list. Let's understand this concept. So suppose like there is a one user A has access up to the Z node of zoo. So it means user A can access the monkey, user A can access duck, user A can access camel. Because user A has access up to the zoo, it means user A can access all these child nodes of the zoo. But suppose there is one more user that has the access of child 1. This is user B. So it means the user B can only access child 1, cannot access folder 1 and child 2 because user B has only access of the child 1. So what we understand it in it, access control tells us till the time we have the access of the particular node, we can access that particular node and its child, and other than that we cannot access. That is our access control list, and that is going to be an important concept for the Zookeeper. Moving forward, we have the states information. The Zookeeper also stores the information of these stats, like example versions that we will see later on. Now we are going to see the most important part of this video, that is types of Z node. So there are two types, persistent and the ephemeral, and these two types can be divided further into two more types, persistent non-sequential, persistent sequential, ephemeral non-sequential and ephemeral sequential. We are going to see what that means. So first of all, before moving to these subtypes, first of all, let's understand persistent and ephemeral. So I've just wrote some of the definitions of persistent and ephemeral. So let's understand them. So suppose the persistent node is there. It means it is going to be lifetime. And secondly, it can have children. Let's understand it. So suppose if I create one node slash a that is going to be in our Zookeeper server for lifetime. Till the time I am not going to delete it manually. Okay, it is going to exist in that particular Zookeeper server. And what will happen? And this particular slash a can also have the children. Suppose example slash a slash child 1 comma slash a slash child 2. So what we understand it, persistent node can have the children. Secondly, persistent node cannot be is going to be into the server till the time we manually delete it. There is one more point that we can know about the persistent node, that is, if we want to delete the persistent node slash a, first of all we have to delete its children. Like we have to delete child 1 first, and then we have to delete slash a child 2, and after these two steps we can delete the slash a. We can not directly delete the slash a if the children are going to be present. So this is about the persistent node. Now we are going to see ephemeral node. So ephemeral node is going to be into our server till the time session is running. So we can simply say these are the session nodes. So suppose I created one node slash e, it is going to be in our servers till the time the servers are running. At the time when the server is going to stop, ephemeral node is going to die. Okay, it is going to be deleted at the time server goes down. Okay, it is very simple. Moving forward, there is one more uh, point of the ephemeral node. The ephemeral node cannot have any children. So if we have to create a ephemeral node, there is no children are going to be there in the ephemeral nodes. Now we have to discuss about the subtypes, that is persistent sequential, persistent non-sequential, ephemeral sequential, and ephemeral non-sequential. Let me just write it down for you. Persistent sequential, persistent non-sequential, ephemeral sequential, and ephemeral non-sequential. The examples are very simple. So first of all, we have discussed about the slash a node, that is persistent non-sequential example, because we have just created one single node slash a. So it is a very simple example. So like we are not doing anything, and this node is going to be in our system till the time we are not going to delete it. We have created a persistent non-sequential node. We have already discussed a recurrent non-sequential node, that is slash e. It is a simple node again, but this is going to be in the system till the time session is there, and it is going to stay in the system lifetime. Ephemeral node is going to be staying in the system for the session. After that, when the server will die, this ephemeral node will die. Now we have to talk about persistent sequential and ephemeral sequential. So sequential means when the nodes are going to be created in the Zookeeper, they are going to be created in such a manner, like in an incremental sequential manner. So suppose if there is a node sequence 00001, then the another node that is going to be created is going to be like sequence 00002. What do you mean by persistent sequential? So this particular sequential nodes are going to stay in our server for the lifetime. Then it will become a persistent sequential. If they are going to stay in our system for a session, then then it will become ephemeral sequential. So let me just give you an example. Suppose there is a node like slash a sequence 00001 slash a slash sequence 00002. But these two nodes can be an example of persistent sequential node. And this particular sequence is going to be created by the Zookeeper, and this is something that we are going to see later on in this video. But this is going to stay in our server for the lifetime and and also managing the sequence. Okay, so this is a property of it. And then now we can take one more example. Sequence 0 or like sequence ephemeral 00009 and sequence E00010. And these two are the example of the ephemeral sequential, where again the sequence is managed 009, and after the 0010, if there is one more node going to come, it is going to be sequence E00011. Okay, but they are going to be in the server for a session. Other than that, if the session, like if our server will die, these nodes are going to be deleted, and of course, sequence is going to be managed. Now what we'll do, we are going to see all these examples in our terminal. So first of all, let me just open my terminal. So first of all, what I'm going to do, I'm going to run my server. What we are going to do, we are just going to do bin slash zk server .sh, and we are going to run it in the foreground. Okay, so our Zookeeper server is up and running. Now what we are going to do, we are going to run our Zookeeper client. Push bin slash zk cli.sh server localhost 2181. I'm already told these commands in my second video where I've just done the single node setup of a Zookeeper. Now, what we are going to do, first of all, we'll run the one single command ls slash. Now you can see there are some folder 1, Savage and Zookeeper. In your scenario, it is going to show you Zookeeper. Okay, but I was just doing some testing. That's why it was showing me these three things. But for in your case, it was just going to show you Zookeeper. So first of all, we'll going for a simple and straightforward, persistent, non-sequential type of command create slash a, as we have discussed, and this is going to be persistent, non-sequential. So now we can see slash is created, and if I'm going to do ls slash, you can see this a folder is there. Now what we can do to check if it is persistent or not, we can just shut down the server. I shut down the server. I am again starting the server. I'm shutting down the client and again starting the client, and it is again connected. And if when we are going to do ls slash, you can see that a is still existing. This means that after our server is down, still the A is going to be present in our Zookeeper client. That means it is persistent, non-sequential. Now we are going to see an example of persistent sequential. So what we'll do, we'll just create one folder slash B. Okay, let's create one folder. Create slash B slash sequence, and we are going to study persistent sequential. So this time what we have to pass, we have to just pass one simple parameter slash s. That means slash s means sequential. So when we are going to run this command, you will see something different. Node does not exist. Oh, okay. So we have to just make a sequence like child of a particular node that is going to be exist. So you will see the a sequence 0000 is created. But what we have just typed here sequence. But automatically, because of this dash s, Zookeeper already make it as a sequence folder. We got this. And if I'm again going to run this command, you will see there is an incremental fashion is followed. We have created one more sequential folder, that is a sequential Z node, that is sequence 00001. If I run it one more time, you will see sequence 0002 is maintained. So we have studied persistent non-sequential and persistent sequential. We can again, this close our server, close our client. Again, I'm going to run the server. Again, I'm going to run the client, and you will, when I'm going to see, and I'm going to do ls slash, you can see that a folder is existing, still existing. And when we are going to do ls slash a, you can see all the three sequences are existing. That means these three sequences and that particular a folder is persistent. So now we are going to see the example of the ephemeral non-sequential node and ephemeral sequential node. So let's move forward. So suppose if I create for the ephemeral sequence, what we have to use? We have to use dash E, and then we have just create a folder slash C, and then we'll simply write ephemeral non-sequential. So when we are going to create this node, this is going to be in our cluster for a particular session, and after that when our client goes down, this particular key is going to be deleted for our system. Now we'll see slash ls slash s. So we can see that the particular C folder is visible. And now if we are going to make a child to this slash C slash abc, so you can see ephemeral nodes cannot have any children. Now what we can do, we can just close this client. And when we are again going to run this 2181, now if I do ls slash, we can still see this T is existing in our system. We already told you that ephemeral nodes are going to be deleted, but it is still showing me. But when I'm again going to run it, you will see that it is going to be deleted. And ls slash, okay, now it is deleted. This happens because of our sync time and the init time that we have studied. I hope you have studied in that particular thing in our third video. And if you studied that, maybe you can understand it why it takes some time from the deletion process. Now let's move forward to the ephemeral sequential. Create -e -s -e stands for ephemeral, -s stands for the sequential. Okay, we can just name it as folder. And we'll just pass the ephemeral sequential node. So you can see the folder is created with some random numbers like 1 at the end. But now when we are again going to run this command, then it is going to be again in an incremental fashion. It is going to be 0, 1, 2. Okay. Now that is created. For getting all these folders and everything, you can just do ls slash first of all to see all these folders. And if you want to get the data, you can simply do get slash folder one and see. Yeah, there we don't put it any value. If I do slash a, then I'll get some value. Okay, so this is the persistent non-sequential node that we have created previously. Now, if you want to delete any persistent node, you have to just do this command delete -a. So we cannot delete -a because in that A folder there are multiple children nodes. For an example of persistent sequential that we were studying previously. So first of all, if we want to delete particular -a node, we have to delete the children, and after that we can delete this particular A node as well. Okay, so this is something that you can try out. So this is for this particular video, and we are going to meet soon in our next video. Thank you so much for watching me, and bye bye.